Okay, today we have Mary Grygleski, Regional Director of the AI Collective, and been giving a talk called Harnessing Event-Driven and Multi-Agent Architectures for Complex Workflows in a Generative AI System. That is a mouthful of a title.
Yeah.
I'll let Mary describe it in more depth, but before Mary gets started, I will just do a few community announcements as usual. First, I want to give a special thank you to DOK community sponsors, our platinum sponsor, EDB. Really appreciate your sponsorship. Of course, without sponsorship, we can't do things like this. Have our virtual town halls and participate in DOK Day at KubeCon. So we appreciate your sponsorship. Some community spotlights. I just want to highlight two of our DOK ambassadors, so Jonathan Battiato and Divine Odazi. So Jonathan has been participating in a bunch of events, but recently participated in the PG Lowlands debate representing the cloud native PG on Kubernetes. So on that side, so we always appreciate Jonathan's efforts. And so thank you. And then Divine, he'll be actually hosting Data on Kubernetes Day, stepping in for me and Melissa. So he'll be there representing the community. So he's the guy you'll want to ask questions if you're going to that event. And by the way, Mary will also be speaking at that event as well. So yeah, speaking of DOK Day, it'll be at KubeCon North America in Atlanta, Georgia and then that's November 10th through the 13th. DOK Day will be on November 10th. Ooh, I don't know if I changed, if it's that's actually Tuesday. Hold on. Let me make sure. I'm not sure if I changed the date. Okay, Monday. Well, we're doing a live change.
Oh, yes.
Monday, November 10th. So yeah, that and you should register for that. So you can use the QR code on the right there, and you do need an all access pass if you want to attend the co-located events. So DOK Day is one of the co-located events. And if you do get the all access pass, you can go to the other co-located events as well. So you're not just limited to DOK Day. So yeah, make sure to register for that pass if you want to attend DOK Day. Okay, and then the DOK survey. So each year we put out a report with kind of that talks about the trends and what's going on in the DOK landscape. In order to write that report, we do a survey. So the survey actually closes at midnight. You probably see some advertisements for it. Closes at midnight, October 17th, which is tomorrow. So if you complete the survey, you'll be eligible to win one of three $50 gift cards. You can scan the QR code there. I also posted it in our Slack. If you also look on LinkedIn at DOK, you'll see links to that survey. So, the survey is only as good as the data that we collect. So if you fill out the survey, that'd be great. Encourage other people to fill out the survey. That's very helpful. So yeah, so do that by tomorrow. It takes about 10 minutes. And yeah, it would be great for the community. And then lastly, if you're just interested in getting more involved in the community, you can scan the QR code on the right. That'll take you to our website, to the community page. Our website is just dok.community. And if you're interested in sponsoring the community, this QR code there takes you to the sponsorship page of our website. So yeah, really appreciate everybody being here today. Before I introduce Mary, just want to let you know that you can enter your questions in the chat, and then I will pass them on to Mary. She'll try and answer them throughout the talk if they're particularly relevant. Otherwise, we'll definitely get those questions answered at the end. So yeah, but without further ado, I'll let Mary take over and give her presentation.
Okay, great. Yeah, now, okay. I'm sharing my screen, but then I can't find. Okay, now I
There it
found
is.
it.
Yeah.
You know how funny. Okay, awesome. Oops, and I little clicked too much. Okay, great. Thank you so much, Paul. Thank you so much for the DOK community for inviting me today to do this presentation. And as Paul mentioned, I will be at the DOK, the co-located event CNCF at KubeCon coming up in Atlanta. So if you would be going there, I will have also like a similar talk, but just to know that one too, I actually touch a bit more onto the flow on the AI, machine learning, the ML ops side of things, but it's still kind of related to a bit more event-driven, cloud-native way too. But this one is a bit more on the event-driven and multi-agentic side, less on the mechanical part, right, of the ops side. So anyway, this is my talk. I will harness event. How do we harness, right, event-driven and multi-agentic type of architectures for complex generative AI workflows? It is a mouthful, like Paul says, and I feel there's actually so much potential, right, to get into the deeper into event-driven technology and apply that to agents to drive the generative AI type of workflows, which to me, I think right now the agentic talk in the Gen AI space is mostly about, I think, a bit more less like, let's put it that way, less enterprisey kind of apps. But event-driven is actually what will enable an enterprise type of situation. So here I am, and let me kind of go ahead. This is the agenda. I'll just spend a little bit of time, and Paul already made some introduction, so I'll just quickly show you who am I, and then I'll get into a bit more demystifying Gen AI and agentic architecture and just bring in this agentic side of things. And then the event-driven world and AI, basically I'm saying really, because it's just not being talked as much, but I feel there's a need to. So I'm exploring in this area. This is kind of a relatively newer talk that I have. And then I'll get into a bit more distributed computing and agentic AI, more on the data engineering side, and applying event approach to RAG, doing retrieval augmented generation, and applying event approach to agents and workflows. So that's kind of the plan. And I know I have like roughly, well, actually now it's less than an hour for this talk. So as such, right, I will be also doing another talk at the KubeCon too, or at the co-located. So then that's about it. I'll wrap up and share with you some information. And first of all, who's Mary? So picture is worth 1,000 words. As I kind of over here, I'm actually taking a bit of a sabbatical, but actually quite busy. I'm helping out the AI Collective. It was born in the Bay Area. And essentially, it's a grassroots think tank organization. It's nonprofit, and all of the chapters, we're helping out as volunteers. So I'm also the regional director for U.S. and Canadian East region. I'm also the Chicago chapter organizers, one of them too. And then other things too is that I'm the Chicago Java Users Group president. I've been helping the Chicago JUG since 2015, so it's been about 10 years, and I've been heavily involved with user community, tech communities. I worked also as a developer advocate after 25 plus years as a software engineer. I started software engineer doing, believe it or not, doing Fortran, and then in the early 90s, just when internet was born, and then slowly get into Java and then open source, and that's how I got into it. And then I also been very honored. I'm also a Java champion because of my involvement with the Java community. And I've been still, again, heavily involved with Java, but I also started getting into AI, into data very naturally. I got into my, essentially too, I should say, my really deep interest too is in computing and with distributed systems. I just love this area that involves event streaming, event-driven architecture, all of these things. So, and then I'll be sharing with you too how you can get a hold of me. But here too on these slides, I show you I'm on Twitter, X, and LinkedIn, and GitHub, and all of these things, and Discord, and all of these things. So, and yeah, so that's about me in a nutshell. So I will start, right, talking about event-driven and agentic. So let's demystify. The reason for this is let's demystify, right, this generative AI thing. It's been all over the place, almost 3 years ago when ChatGPT came out from OpenAI. And then, it's been amazing. But if you kind of look at it, right, it's not like it's new, but it's funny too how, we work, I'm assuming all of you or most of you are working with computers or computing data, whatever aspect, right? We're dealing with computing. And then actually too is that AI, as we all know, is not new. It came out essentially in the last century. But of course, it's evolved over time. But as we can see too, I wanted to give kind of like set the stage first. So let's take a look, right? On the left side, I have this kind of a simpler, very simple description of saying AI is mimicking the intelligence or behavior patterns of humans or any kind of living entity. And then inside it, you go deeper machine learning that's kind of involved all of the learning from data. And also, too, what actually makes things really happen is the deep learning, really the core part, the neural network. So if you move over to the right diagram, I dissected a little further. It's still very extremely high level, these diagrams. As you can see, Gen AI kind of sits in the intersection inside this core of the AI diagram. And also Gen AI makes heavy use of NLP, natural language processing. And that's what I think it's been amazing because of the first breakthrough, right, with using NLP. Although I have to say, well, Siri came out first before Gen AI too. And that's also a big breakthrough. But for Gen AI to be able to take in commands in the form of spoken languages through NLP, it's really a breakthrough in there, which means no longer do we need to be talking to computers and ask the computer to do work in a very rigid way. Think of the fact that when we first started learning computers, we have to program, we have to follow very strict rules how you give the commands, right? Even like the type of input, is it string, is it numbers, all these things. And it's, from the programmer's point of view, it is quite a lot of work. You have to parse it and do all these things and identify all these things. But now with natural language processing and also having the large language models being able to interpret things is quite amazing. But as you can see over here, okay, without further ado, data is really at the center, the core of this whole thing. Without data, there's no AI, or at least AI is working without any purpose, and machine learning, all of these things. So let's go kind of move on. But here too is essentially, I wanted to set the stage, is Gen AI essentially it has been infused into all fabrics of our lives. We are no longer, well, actually, I should say we are all producer. I'm assuming all of you are builders or developers or some sort of, you're technical people, but we are also consumers. We are consuming, right? For example, as developers who use GitHub Copilot, we are consuming, we're using it too. But at the same time, for developers, builders, we are building apps, we're training models, doing all of these things. And of course, these are like the handful of all of the kind of prominent generative models. And I won't get into all of these, but as we can see, OpenAI is kind of first and foremost. And then, of course, then once it came out with ChatGPT, then all of the other models came out, and also the multimodal side and everything too. So I won't get into all the details. And there are also platforms too that can do things, but they kind of, for example, Amazon or Microsoft platform, Azure, Google Cloud, all of these, they have their own kind of enhanced kind of cloud-enabled type of AI platform for developing apps easier too. Now, however, let's kind of get into a bit serious stuff, right? We see all the magic. It's becoming more what you call it. Gen AI came out. It's actually brought this to the mass media. Think of the fact that before Gen AI, somehow, right, when we needed any kind of AI types of work, we have to go to our AI team, to our data team, a machine learning team, to ask for permission to use their systems or ask somebody to do things for us. But right now we can do things on our phone. Little kids, anybody, grandmas, who non-technical people can use it and ask questions. However, just think of it though, all the magic is done by LLMs, large language models. It is powerful, don't get me wrong. There are plenty of very complex algorithms to analyze all of the commands that comes in as prompts, and then able to figure the things out, and then have the LLM kind of take care of things, and take care of business, interpret what's needed, and answer back. But recognize that there's also a lot of limitations too. So I think that's where we need to demystify, right? And I'm assuming most of you have worked with it. So without further ado, let me kind of get into, what the limitations are. I think first of all, right, there's no memory in LLM itself. It's just, think of it as like a giant machine. You kind of, give it the commands, it will search. Actually, it doesn't even do search, strictly speaking. It's doing a series of complex algorithms to do pattern matching, look for the answers for you. And basically, too, as such, the algorithms is very non-deterministic. So the results, too, as a result, is probabilistic, too. If you ask the questions, same questions 10 times, it will come back not exactly the same. 100 times, same thing, not exactly the same. And I think there could be chance of it being exactly the same, but the chances are quite low. And it's all because of this non-deterministic nature of the model, how it works too. And of course, too, it's opaque too, which means you cannot add attributions to its answers. There are no memory. It cannot keep track of the state. Now, the thing is too, you might say, well, we can do it now. We can go to ChatGPT, ask questions, and it would kind of seem to remember. Of course, because that interface has built-in capability to actually extend what LLM is not able to do. But LLM itself cannot do much beyond, just crunching all the commands and kind of spit out what you're asking for. So in other words, right, the thing is that the hype is there's one-shot usages, right, or zero shot. You ask the question, you have to kind of phrase it exactly what you are looking for to get the right answers. It's pretty much just a one-shot deal. It can do very well. You can ask it to write an essay, do some things. You can ask it multiple times to do things for you. Yeah, no problem. But then, if we're kind of thinking of, okay, we need our world is complex. We're living in, complex, kind of day and age. We all each have so many things to do. It's like we can't just sit there and wait for one thing. We actually, are living in complex times in which, for example, we need to make flight reservation. And of course, that will take many steps because you need to look up all the flights, you need to compare what is the price, and then eventually you need to, go through saying that, oh, I picked my flight. I also have to check my calendar, making sure that it doesn't overlap when I'm flying, any kind of important things. So those kind of things, right? They're complex and they kind of involve a lot of data and dealing with different systems. So in other words, we're talking about, systems that involves multiple steps and all of these things. And that's when like agentic systems kind of come into play. Now, everybody talks about agents, and that's how I'm looking at it. Yes, no doubt, we need agents to do things. Agents will leverage LLM's capability to do what we need it to do. But the thing is, though, if you think about it, LLM it cannot scale, at all by itself, and also cannot handle complex tasks. You have to have external libraries to extend the capability, and that's why it's like through agents. And also, there's no memory. It cannot remember the state, right, for enterprise level kind of usages. So now comes agentic architecture. So as such, right, agents to itself, this concept is not new. And if you are in computing, you know that it is, even like not AI, AI or not AI, agentic architecture is its own beast, right? But the idea, though, is that in AI kind of context too, is that we want to take a look at it, what would be kind of needed, right, in AI kind of environment. So the structure and design of AI systems that leverages on AI agents to perform tasks will need to be able to handle like autonomous execution too. So because of AI's capability, it needs to be able to figure out what steps to take, for example, or if something happens, what should happen next, making predictions, for example, those things kind of autonomously. That's the ideal scenario. The agentic architecture should kind of handle that part. And also, too, not only that, right? We are now talking about multiple steps to do things. So therefore, we involve not just one tool. There are multiple tools, or even like multiple LLMs that, the agents are all interacting with. They need to be orchestrated. The answers, the final results, whatever it is, the outcomes needs to be properly orchestrated. It needs to involve different tools. We need to integrate things. And then there are also scalability aspect, and in a simple case, it's no need for maybe one user asking question. But let's say I'm trying to make flight reservations, and there could be a spike during holiday time, for example, like Christmas, any kind of like summer holidays. We know, flight demands are high, scalability, right? So we want that this whole architecture to be scalable too. And not only that, we don't live in a perfect world. So there's always something that goes wrong. Oh, I booked the wrong flight, user error. I need to roll back, doing all of these things. So we need to make sure the agentic architecture is very resilient and also can recover well too. Now, ideally, it ought to be able to recover by itself and very resilient, like self-recovery. But that's also like something's kind of in the works. So as you can see, this agentic architecture, we take it to another level, is actually quite complex. key concepts. Let's get into agentic architecture. So basically, you can have vertical architecture, which means one agent can be leading, right? Can be the leader to decide what to do. All of these things is sort of a vertical architecture. Or you can have horizontal architecture, which means multiple agents can be collaborating. And then you need some sort of agentic orchestration. It's like orchestra. You're playing, you have different instruments that are playing each to their own part, own kind of part, but all of the music needs to come back in a very coherent way. So in other words, we need also some agents to be the conductor, right? It's like an orchestra conductor too. So orchestration of these things, and it's agentic, done it in an agentic way. And then there are also the task execution itself can be very complex. Maybe certain things cannot happen until something else happen. All of these things, you need some way of triggering if some event happen, and then it needs to trigger another agent to do something else, that type of thing. So it's actually this kind of agentic kind of way of doing things is kind of jives very well with event architecture, because that's the idea of event-driven type of architecture, is that maybe some code too, you don't need to explicitly write it out, but you can have code there, and it's essentially some action gets triggered when certain events happen. So it kind of jives very well with the agentic architecture in this AI type of usage scenario with like event-driven architecture. Now, another thing is go down to is autonomous decision making, and that's actually something is very AI specific. You want the agent to be able to help to reason and plan things, but as such, we know that right now we are still in AI stage, and there's AGI, which is artificial general intelligence, which is now something that the big companies, such as OpenAI or Google, all of these, they are kind of working hard to get into AGI to really make the LLMs, the model being able to reason. Now, I think personally, I don't think they can truly reason, kind of, it can't really take the place of humans. To me, I think human beings still need to be in the center of things, but they can certainly help and speed up with a lot of processing too. So, but that part is good, still autonomous decision making is good if you kind of think of doing AI stuff and have some of the things we don't need to deal with the tedious, the mundane. Let the agent kind of take care of us, of things for us. Now, another thing is also like continuous learning and adaptability. Now, in the same line, kind of spirit of doing machine learning, there's no need for us to kind of like, actively training these models. It's basically we let the model learn from the data. So this continuous learning kind of aspect is also very important too in agentic architecture. And then also, ultimately too, it's basically saying that there's no human intervention. But here I'm saying that really, do we really don't want human to intervene? Now, in my opinion, I don't think so. I really still feel human needs to be at the center of, kind of controlling things is what I think. Okay, now let's get into event-driven world and AI. At the heart of AI is data. So now this group, DOK, data on Kubernetes, we're called to attention. We are dealing with data as such, not just the data itself, there's a flow of data in many directions as well. So let's kind of take a look a bit, kind of on the technical, looking at data and the tooling. So on the architecture level, as I talk about, we can have event-driven type of architecture that's basically, as such is driven by events. The events kind of determine what actions will happen accordingly. And then also too, if you look at data too, and within data itself, there's also different state that we can describe it, right? It can be at rest. And so in other words, it can be in some form of storage, such as database, very common, right? Database, relational database, object database, or, any kind of NoSQL kind of database, whatever it is. And then there's also file systems and also like other storage as well, and these are just some examples, cloud storage, but they are essentially also kind of file system too, and some form, I should say. And then also too, data can be in transit too. Data can be, kind of, we need to send data from node A to node B in a network communication, the different nodes within Kubernetes, and they are in transit. The data is not going to sit there in one node. It will be waiting to be transported to another node load accordingly. And then also in use too. So it's basically, these are software when certain data we are dealing with, for example, order entry. So some order data, I place an order, the state changes of the order, if it comes in as new and then being processed and then later saying that in process and being, waiting for payment, whatever, and then in delivery stage or it's done, for example, right? These are simple case. So they are kind of going through different stages, but data itself is being in use, being transformed at that time. We need to do some computation and update the data and upload it or update it and then send it back to some storage, for example. So those are kind of data in different states. And then there are different techniques too. So that's the thing. So when we deal with it, we're talking about event streaming. Now, some of these I'm listed out here. I do have to kind of admit, maybe I'm a bit more, because I work with Java a lot, so I'm kind of giving examples of streaming kind of tooling that are more Java-centric, but these actually are not just for Java. For example, you can use Python to use Kafka, to use Pulsar, Red Panda, or Solus, all of these too. So those are kind of examples. You can use them for event streaming or using for event messaging. For example, Kafka and Pulsar, they use broker, right? So these are broker that will be receiving messages when they get published by the publisher. And then also, if there are clients that are interested in the data, they can subscribe to that particular topic. So then when there are messages arriving at the topic, and subscribers to those topics will receive messages. And these are the broker is there to handle. So that's kind of event messaging using PubSub type of way of doing things. Or you can use queues too. So queues are more like it enters into a queue, first in, first out. So whoever is there, maybe some processing message queue, you have to process it as such, first in, first out kind of manner too. So all these Kafka, Pulsar, Red Panda, they can all do it as well. And then there's also another technique called event sourcing and CQRS. So that's actually quite interesting. Because what happened is that I can use an example why this is actually kind of an important kind of techniques too. As such, right, I like to use the example of, let's say, an order entry. So let's say you place an order for, I don't know, some stationery supplies, from Home Depot, not Home Depot, Office Depot or something. So anyway, so that order will enter your database. In traditional sense, we can have one order entry, and then there's a status field, right? That will kind of keep track of, is this order just initial state and then doing something like being vetted and being like in process, or another thing is waiting a different state. Now, however, using such way of keeping track of an order may not be ideal, because at any given point in time, you can only know the latest status of this order. But what if there's something goes wrong, I want to trace back, right? So that's when like event sourcing will become very helpful. Event sourcing essentially is that you want to keep track of the state changes of that order. So in other words, anytime there's some important, changes in the state, you want to log that column. So in some ways, it's like logging, So in other words, actually Kafka is sort of an event logging, has that mechanism. Pulsar, Red Panda, all of these too. They are essentially, you're keeping track of that order, but any given point in time, you log that status once is changed to that. So then anytime there's also changes to the state, you log another entry. So yes, it is true. You will keep track of the same order having many entries, because you are keeping track of the state changes at any given point in time. But look at, this is a good way. If there are anything that goes wrong, you need to do backtracking, doing tracing, debugging. You can actually take, let's say, some order isn't go right. I can actually extract that whole set of records and analyze at what time what is happening to that. So you can do debugging much better. So that's an example of why event sourcing is becoming useful. And then there's also a technique called CQRS. It stands for Command Query Responsibility Segregation. You basically have to help, because the way of this is doing, we're doing it this way. So there are lots of writes too, and then also you can have many reads as well. But you want to separate out this. So this pattern is essentially separate out the read and writes too, with the storage aspect of, trying to read from and also write to kind of aspects too. Now, this, I won't get into all the details, but I just wanted to point out too, it's an important aspect of data engineering. So now let's get back a bit into like generative AI streaming usages, right? So kind of if you kind of look at it, I think all systems essentially have some way that we can leverage on streaming. Streaming as such, we're describing, data is basically essentially traveling all the time. And in generative AI type of systems, there are prompts, right? We need to send our command through command line or through different internet browsers that are on devices, can be internet or kind of on our desktop or on our cell phone, whatever, some kind of small device as well. And then also mobile apps, for example. So these are prompts that can be streaming at any time too. There's people coming in and have a prompt asking for questions and we need to process. And then the next step is intermediary steps. So if we're using retrieval augmented generation types of operations, then we are also talking about we need to connect to the data with generative AI to extract data from some external sources, such as database, file system, can be also sockets or message queues and Kafka topic, all of these too. They can be different source because RAG is essentially supplying additional data to the LLM that it did not get trained with. We want to increase the context window that way as well. And then also too, you kind of take care of the input data, but you also then after that generate in a generative AI scenario, RAG application, you need to also send the request to LLMs that can also be sent through streaming as well. You can actually be setting up another Kafka topic, for example, that actually once the updated prompt is ready, you can send the prompt as another topic, to and as another message to a topic that's for LLM, for example, to pick up something like that, right? So I'm just kind of giving an example. And then, of course, too, LLMs will do its thing and do pattern matching or searches and then get the answers back, and that gets sent back to the generative AI, the requester as well. So those are kind of streaming usages. Now, benefits of the event-driven approach, why do we want to consider that? And as such, right, we're talking about the nature of data is very dynamic, right? And also flow patterns too. They are not just sit there. Nothing is static. We have to assume that in kind of a very fluid type of systems that does many different things too. And also too, another thing is with event streams, you really can truly be enabling data, the communication to be done asynchronously because we're now talking about using like a pub/sub type of interface. So then it enables messages to be sent at any time when it happens, and it can be processed asynchronously. In other words, a client comes and messages is here. I can pick up the messages when the client is ready. I don't need to do it right away. Maybe I'm busy doing something else, and so when I'm done with another task, I can say, oh, another event happens and the data is there. I'll pick it up then. So it's kind of very asynchronous. So as you can see, it helps too, right, with scalability. In other words, if all of a sudden you get a lot of messages, then you need additional brokers, and you can actually add brokers to your particular system scenario as well. And so very dynamic, very scalable, very flexible. In other words, all of these components, they are all independent, but they operate kind of together in a very loosely coupled type of fashion too. And then also too, this kind of model also helps with integration of very diverse AI models and services. We're talking about different agents, and maybe I'm an agent that handles more like code generation, doing like code. So I work with Codex, which is like the model behind GitHub, no understand code. But then I'm also at the same time needing some model to handle video data. So now I'm using, let's say, Sora, right? OpenAI Sora, and I have another agent doing that. So it helps too in this sense. But the thing is to be aware of the challenges, right? It's more difficult to debug, and it's also harder to track the flow of calls and the data they carry. So that part, right, observability will need more work too. But it's just like anything else. We benefit from one side. We also have to take care of some things that may be harder to do, more difficult to do, but it's all possible. We just need to be aware of what needs to be done. Now, distributed computing and agentic AI, data engineering side. Now, this I can't avoid but wanting to also bring up is the CAP theorem. So there are three fundamental aspects, right, of data. And if you're, it's just for those who may not be aware, just wanting to kind of brought that to your attention, CAP theorem, and that's something I'm also been starting to think of, right? So essentially, what CAP stands for is consistency, and then availability and partitions tolerance. So this theorem, what it says is that only two of these three aspects are guaranteed. So what does it mean, right? Let's take a look. Consistency. So basically, we're talking about every read, is from the most recent write, or there will be an error. So in other words, right, any kind of data in a system, in a distributed system I'm talking about. So when we read, and any kind of read that comes in, they should be consistent, right? So they should be consistent and needs to be also from the most recent write. Now, the thing is too, is if we look at the next criteria, this aspect is the availability. Now, every read will always get back a response, but not necessarily the most recent write. So that's availability. And then there's also this aspects, I think it's a bit more controlling because in a sense, in the distributed computing, it involves components located in different locations. It can be across the network too. It may not be, right, or something, but still, the network aspect is very important, is the core, is the partitions tolerance. So partitions refer to network, the network thing. So so what happened is that it can be in cases in which there's a network failure, maybe something happens, the internet is down. But the thing is too, we're talking about the tolerance is that the system needs to continue to operate regardless of these issues. There's no connectivity. So in that case, then what do you do, right? So you have your software. Do we honor consistency or do we honor availability? What do we do? Now, in the cases, basically saying CAP theorem says that only two of these three aspects are guaranteed. So in the case of there's no network connection, so you could have a systems that basically to do honor consistency. So in other words, in that case, you will suffer, right? Availability will suffer, which means you need to wait for the network to kind of come back to in order to make sure that you can get data from the most recent write. However, in a Gen AI, especially that type of usages, I believe that Gen AI is a bit, kind of wanting to be more wanting the availability aspect, which means whenever I need something, the Gen AI would need to get back a response, regardless of whether it is correct, the most recent write or not. So that's availability. So as you can see, right, you can say, well, I want to be more responsive, so I'll always provide a response regardless of whether the network is up or not, or down or not. So in that case too, what will happen is that what we believe is that there's also another kind of concept in which we're saying that, well, we can be available because we believe in eventual consistency. So we believe that network will come back. So in that case, eventually the data will be consistent that way. Or if you really want to be consistent, then it tends to be less performant because I have to make sure that the network is always, kind of up, so then I can get the latest. So as you can see, these three are sort of like interesting kind of aspects that we need to be considering. And this one too, I wanted to kind of point out a little bit. So in other words, with the CAP theorem, we also need to kind of decide what type of database would serve our needs, right? So we're talking, let's say, about Gen AI type of scenario. So if you look at it, we look at A, right? Gen AI is more availability. Then you can kind of, you look at, kind of examples such as React or CouchDB. These are more availability kind of heavy on that. But there are also like partition tolerance, such as DynamoDB or Cassandra, Apache Cassandra of Voldemort too. So these are like, in spite of network partition, it can actually always be serving up data like that too. Now, kind of looking at consistency too, you can look at, like, for example, actually, I should look at the right side. Well, these, as you can see, they are not, kind of like favoring one or the two, but they probably are built a little bit more leaning towards one versus the other is what it is. So Oracle, for example, MySQL, all of these, they tend to be more based on consistency. So maybe performance side may not be as good. But I think over time, for example, Oracle has more support for the availability side as well. But if you look at the left side, Google, Bigtable, MongoDB, all of these are a bit more like partition tolerance, that part as well. So anyway, so this one, you can also kind of do a Google image search and kind of get an understanding to help you to decide which database to use for your particular use case as well. Now, there's also another extension to CAP theorem if you're, Purcell. And this one, it stands for partitions tolerance, availability, consistency, else latency and consistency. So this, now I won't kind of get into all the details, but then it's kind of an interesting kind of concept as well. So the theory, the concept behind it is basically saying that even without partitions concern, right, consistency and availability would need to make some compromise between the two, because you can have partitions tolerance and then you can have availability or consistency. Otherwise, too, you still need to kind of worry about latency. Is there a need, right? And if I'm doing Gen AI type of scenario, is it important, to be more available for the data, or do I need to be waiting for more consistent data because I want to wait for the network to come back like that? So it's a very interesting kind of concept to it that kind of like extending the CAP theorem as well. So I just kind of wanting to bring this up too. But the thing is in here too is basically Parcel reframes Gen AI too. So if there's a partition issue, you want to choose A or C. That's CAP theorem. Else, in the absence of partition concern, you still need to trade L, latency versus consistency as well too. So that is something you need to do. And then for Gen AI, users expect streaming tokens to be less than 1 to 2 seconds, which pushes you toward low latency reads, and often with eventual or session consistency, except for a few critical subsystems that must be strongly consistent too. So I think in a lot of cases, if you don't, if the data itself isn't as critical to be consistent, to be the most accurate, you can actually go for availability, is what it is saying. And Gen AI tends to be the case. But it also explains perhaps a lot of financial companies may not be so much ready to use Gen AI just because of this aspect. Because for banks and financial, you cannot actually have your data to be inaccurate, right? You're dealing with money. They need to be exact. They need to be deterministic as well. So there are also different ways to make it happen. So CQRS and agentic AI, let's kind of take a look at this. Actually, I already explained it earlier, but it's just a rehash. It's a software architecture pattern. It separates out the data models being used for writing, for the commands, and also for reading is the queries. And it impacts data storage requirements too. So if you are working with that, that's an important aspect to pay attention to. And it suits very well to the dynamic needs of agentic AI systems, right? The serious types of agentic end-to-end enterprise systems where scalability, concurrency, and performance and resiliency matter too. So CQRS is a pattern that you can consider be applying to agentic AI systems. Now, let me kind of really quickly then go over the event approach to retrieval augmented generation. Let's just a quick kind of rehash for those maybe new to this concept. So it stands for retrieval augmented generation. As such, right, LLMs itself is trained on data that often is very old, it's expired already, because you need to essentially take a snapshot of the data at that point in time and start training, and the models would take some time. And I didn't even actually recall myself emphasizing that Gen AI, well, or actually large language models is expensive. It's primarily because of that, because it needs a lot of energy to be trained. It takes a lot of time, right? And like that. Anyway, so there are also like data that LLM doesn't have. So that's when retrieval augmented generation, this pattern comes into play. Now, understand that this isn't something that's implementation. It's more about architectural level. These are more on the model level. And its purpose is to enhance the LLM and give it more data extended to it too. So let's kind of take a quick look, right? So over here, end user, I'm submitting a prompt to the RAG applications through prompts, and then RAG application will then go and do a vector database semantic search, right? And essentially too, it also can be not just database, it can be other forms of database. For example, I'm in a regular company and I need to read data that's not trained in the model. And plus, sometimes too, let's say a legal firm, right? I cannot expose my private client data to the internet. So I have to keep track of my own database. It's all behind the firewall. So that type of stuff. So the RAG will kind of draw data from its own private source or any kind of real-time source. And from there, doing semantic search, for example, in vector database. And then from there, it will enhance the original prompt. And essentially adding more relevant context to the LLM and tell the LLM and said, okay, now I'm looking, user is looking for something, but I need to make sure that the context window is also being extended to include those data and give it to the LLM, have the LLM process it, and then look for the answers and craft it up. And the generative AI or the generative model itself will then craft up the responses in a very palatable way, so to speak, and send it back to the user. So that's the idea of a RAG. Now, bear in mind, though, I'm not talking a bit deeper too. All of this stuff, for example, when we are dealing with especially handling external data in bulk, that actually will involve, to a certain extent, right, some chunking too, because as such, LLMs has also limited context window itself, right? As such, I think the models are 16,000 K, something around that, right? Or maybe even bigger. Still, the data itself can be huge. So we'll need to split up the data, the input data, in different chunks too. For example, we're reading from PDFs and things like that. So it needs to have special techniques, and that will be, I won't get into detail, but that will be left for another talk to kind of get into the techniques like chunking, filtering, all of these other kind of techniques that's necessary. So yeah. And so just wanted to kind of talk about then the role of the retrieval model. So in a nutshell, retrieval model acts as a special librarian. So it pulls in different relevant information from a database or corpus of documents itself. And then the information from the results to eventually will need to be passed from the LLM to the generative model. It acts as a writer. It crafts up coherent and informative text based on the retrieved data too. So this retrieval and generative model works in tandem to produce answers that are contextually rich. So that's the idea. So here too is just a repeat of the generative model. So it has the capability to create text that's grammatically correct, semantically meaningful, and aligned with the initial query or prompt too. So as such, right, these are kind of model. They don't dictate how things are implemented. So as such, we can see too, if we're using, Python, there's also like LangChain and other, for example, like Haystack, things like that. They actually will have RAG kind of library information, or like in Java, we also have Spring AI and stuff like that that helps with RAG too. Okay, so now let's take a look. I think my time is sort of running short, so let me kind of hurry a little bit now. Getting into agents and workflows again. Event approach as such, right? To me, I think is kind of, they jive very well. So let's take a look, right? Going back to some fundamentals, agents is one who is authorized to act for or in the place of another. It's essentially a computer application designed to automate certain tasks too. Now, one kind of important actually aspects of agents, computer agents, is that it has the capability of being being transformative. So agents could be handling certain processing, handling certain data, but it has this power, or kind of a delegated kind of power, to help with data being transformed as well. So agents and agentic. Gen AI agents, right? So yeah, within software context, just a minute. Yeah, okay. So just a minute. So sorry about that, folks, because I'm in a share space, but I'll finish this up first. So software, right? We're talking about Gen AI agents being able to orchestrate complex workflows and coordinate activities of multiple agents, process logic, evaluate answers. And these are things that is kind of a repeat of what I did earlier too. Now, then get into multi-agentic systems. Now, very often, because each agent is only kind of tasked with specific tasks. But in a complex system, especially complex system, we will need multiple agents that can work autonomously, and they need to work together, and they need to each specialize in different tasks. So now we are talking about agent to agent interactions as well. So that will be kind of the next step. Not only is agents able to process things, but it needs to become aware of what it is around it, what kind of other agents I can reach out to. If I don't have the answers here, I need to reach out to another agents. So we're talking about emergent intelligence from agent interactions. Agents needs to be able to manage subtasks and essentially handle some complex task scenario, and divide tasks up into manageable subtasks. and then also leverage strengths of different AI models. And also, too, the idea is to be able to increase the robustness and fault tolerance of the whole agentic systems as well. So we are kind of looking at agents as being, able to be handling kind of complex kind of scenario too. So let's kind of take a look at the next thing, which is MCP, Model Context Protocol. I'm sure some of you, if you're already working with it, this one is essentially is a protocol that came out from Anthropic. The company is also a LLM maker, kind of a spin-off, I guess, of OpenAI as well. So it is MCP. They came out with this, and now it has been spread, right? Kind of like wildfire, because everybody is now trying to build MCP server, MCP client. It is actually an open protocol that standardizes how applications provide context to LLMs. So as such, we know when we work with different components, there's always that need to integrate, right? There are also resource management that we deal with where we're interacting with certain LLMs or interacting with agents, all of these things. There are different, contexts too, and what database is it connecting to, what kind of network and what Kubernetes and nodes and all of these things, for example. So we need a standardized way to kind of handle that aspect. So then let's say I want to change, my client to be working with another model, another kind of systems. It makes it easier too. So in other words, it provides a growing list of pre-built integrations that your LLM can directly plug into. And also you can flexible to switch between different LLM providers and vendors. And this sort of is a best practices for also securing your data within your infrastructure. But my understanding though, I think MCP hasn't been addressing a lot of the security aspect, which is actually a very important aspect of doing any kind of applications and especially dealing with agentic type of application. But I do believe they are working on it right now, but I want to kind of point that out. Now, there's another agent to agent A2A protocol from Google, which just came out in June during their Google I/O event. This one too, at first too, when I read it, I said, "Oh my gosh, that's how the market goes, right? It just comes out with the same thing over and over again." But yet, when I read it too, I realized that they are intentionally doing this as complementary to MCP, and I kind of copied this over that basically A2A complements MCP. So let's kind of take a look in here. This diagram. As you can see, right, we can have different agents that are doing things, and they are local agents, for example, on the right side, and then it's interact with some LLM, and then it's basically has also an agent framework that actually handles interacting with the resources on the infrastructure side. So as you can see, the way it's kind of positioned is that MCP handles a bit of the lower level kind of concern. I mean, lower level in the protocol stack, right? So I'm like talking about APIs, enterprise applications, how do I, what kind of database and what kind of network and Kubernetes, whatever, nodes. All of these are more infrastructural concern. That's what MCP is concerning itself with. Whereas agent A2A protocol really is truly a bit of a higher level on the application side, on the agent, not exactly application, but at least agent too is a bit on an abstract level. It's basically delegating all of these things through an agent framework that talks with the lower level. But between agents, right? If I'm like an agent dealing with coding, but I also have to deal with video generation, and then I don't have the answers, my agent should be able to reach out to another agent, let's say the one on the left side, to do things, right? To do whatever is needed to do. So that's the idea. So they kind of complement each other. So now I do believe I may not have as much time, but I do want to point out I'm going to be sharing this slide deck if you want to take a look at. We want to combine EDA, event-driven architecture, and multi-agent for Gen AI. So you can kind of take a look at these two. What are the different components? Event bus, API gateway, agents, AI models. So in other words, we're trying to integrate event-driven architecture and accommodate what Gen AI operational side should be doing, right? The workflow, all of these things. So and event types and agent types too. So there are also different types you need to sort out. But I promise you, if you go to KubeCon, going to the CNCF, the data on Kubernetes co-located, I'm gonna try to be showing you a very basic example of like coming up with these agent types and doing like a small demo. So yeah, if you go there, please look for me there. So. Okay, so now let me kind of quickly, before I end, to just sharing a couple more things about agents too. AutoGen has an example with different types of LLM agents, including humans in the loop. So this I've also shared. It's also a paper on archive.org too. So please take a look at it because this we're talking about multi-agent conversations and how there's also human in the loop that's involved. And AutoGen is, by the way, is the Microsoft agent framework too, as open source. And then agentic design patterns. I wanted to also point out a little bit too. Within agent, right? There are also within kind of working with agents, there are design patterns too. And now this one I took actually from Dr. Andrew Ng. He's the AI funds and AI, the deeplearning.ai. And he's really great. I've been following him. And he point out a couple of the design patterns for agentic. Now, bear in mind, these are more higher level, kind of on the agent side. We're talking about reflection, tool use, planning, and multi-agent collaboration. So let me take a really quick look, really fast, quick look at this. Right? So reflection. So basically, too, over here, right, we can be using an agent to help us with coding. So we use one agent called Coder Agent, and it interacts with the proper LLM. And here I am, right? Dr. Ng is asking, please write code for some task and specify it. So the Coder Agent will go in, work with the LLM, generates the code. The first round, what will happen is we also have a critic agent, or what we also call eval agent. So that agent's work, the critic, is to try to evaluate and check the accuracy of what gets generated from the coder agent. Now, critic agent is going to be very, very sharp and kind of find faults with coder agent. So it will come back and say, something like, oh, there's a bug on line 5, please fix it, blah, blah, blah. And so coder agent takes the input and go fix it, comes back, same thing, gives it back, or the critic agent will immediately also run some tests and found out, oh, it doesn't work, please do it. So on and so forth until it gets clean code, from the critic agent side, and the coder agent's work is done and pass it back to the requester. So that's a reflection pattern. I thought is kind of interesting. And then tool use is basically an example and it's basically showing tool integration. So if, let's say, right, I am asked, my agent is kind of charged with answering some questions, to the LLM, but LLM doesn't have answer, then basically the agent can also look up. I'm providing him some help, giving it some external tool. And for example, in here, I can say, oh, go to Bing Copilot, go to Wiki Pages, and basically agent can leverage on this external tool use to help answer the questions in case the LLM doesn't come up with anything, proper. Okay, this one is Crew AI. I will skip for now, but there's also planning. So basically, too, this planning is interesting. It's basically, it's also, Dr. Ng has said in his paper 3-4 months ago, or 4 or 5 months ago, it's basically saying that this actually is still takes some time to become more accurate. Essentially, too, you want to give the LLM, present him a picture, an example, right? A complex thing, an image of a boy riding a scooter, and ask it to generate another picture with a girl reading a book. So same kind of pose, but we need to figure it out. So then in that case, you let the agent to figure out what are the steps. It needs to kind of figure out all of these things. So at this point, I don't think it is very accurate yet, but that's the thing we want to try to reach at is the planning side of things that we want agent to be able to do. Last but not least, this actually would be something would take some time to do is the truly multi-agentic collaboration through an example of an IT development project, right? So you have waterfall model having designer, coder, tester, documenting. So they have handled by different agents and they all work together. We also have a project manager that overlooks, make sure everybody is doing the right thing. Now, there's also an example in here. I give you this link to that article that also points to the this true example inside a GitHub, like a prototype. So if you want to try that out, yeah, kind of check that out as well. Okay, example of a few multi-agentic library. I mentioned AutoGen. There's also Crew AI, LangGraph. These are all like Python. And then there's also Strands from AWS and Agent SDK Google. And on the Java side, if you're a Java person, there's Quarkus. There's also integration with LangChain 4J, CDI, all of these things too, the links in here. There's some code examples from Crew AI. And if you're Java, I kind of recently found out this JAI-workflow. If you want to check that out, I realize my time is running short. So challenges. Let me go into that. just make sure that, Gen AI is still not very kind of safe to use in some sense. The security side is very energy intensive, energy hog. Hallucinations still happen. AI safety and responsibility, you have to remember that. Prompt injection as well. So with that, I kind of want to thank you. I kind of tend to talk too long, but the resources, if you are interested, this slide deck can be accessed from this QR code and also from this bit.ly link as well. Now, I'll be sharing this too with Paul, so then you can reach out to him if you miss it too. And then there are different links too in here. I've also written an article on Java Advent Calendar about event streaming and Gen AI usages. And also I have a Twitch stream and also YouTube channel if you want to follow me there. I'm trying to go back to resuming my stream. And this is how you can get a hold of me. I'm LinkedIn and Twitter or X, and also my Discord server. So with that, I want to thank you so much. I think I'm not leaving you much time left. Thank you so much, Paul. Thank you, everybody, for sitting through. And I welcome any feedback and suggestion and connection too. Thank you so much.
Thank you so much, Mary. I really appreciate it. Yeah, I know you have to run, and we're also hitting up against the hour. So
Sure.
I'll encourage people to reach out to Mary. Maybe on LinkedIn, is that a good way to reach you if they have
Yeah,
questions?
that's right. LinkedIn is good. Yeah, Discord, if they really want to have more conversations, it's easier to communicate on Discord too. But LinkedIn will also work. Thank you. Yeah.
Okay, yeah, no, thank you so much. I really appreciate it. I mean, the way you, I really love the way you presented this
Thank you.
described it in a very understandable way. So,
Oh, thank you. Thank you. Yeah, I hope so. Thank you. So,
yeah.
yeah. Mhm.
Well, yeah, thank you for your time. Thank you everybody for attending. Like I said, we're kind of running up against the hour, but because there was so much to discuss there. But if you have questions, definitely encourage you to reach out to Mary. And then Mary, thank you again for taking the time. I know you have another panel to
Another
join
panel.
right
Yes,
now. So
1871 if you're in Chicago. So, yeah.
yeah, so thank you so much for taking the time
Thank
to
you,
speak with
Paul.
us. Yeah.
Yeah,
All right,
okay.
and also if
Wonderful.
you're at KubeCon, DOK Day, North America, you can catch Mary there and ask questions in person too.
Yeah, wonderful. Thank you. Thank you.
All
Thank
right,
you.
thanks so much.
Have a great day.